Hello, my dear students. Welcome back to Success EduTech. Thank you so much for the beautiful response to my previous lecture. The last two lectures which we attended were based on work. The chapter name is Work and Energy. So the previous two lectures covered the topic work, and today's lecture it will deal with a detailed study about the concept of energy. As per your syllabus, I have covered the points of the energy. But, but as you proceed further in class 10th, 11th, and 12th, you will come to know that the concept of work and energy is very big. It is very vast. It is having so many forms of energy, so many applications. But here you have only few form of energy, their definition and their formula. That is it, and one or two example based on those formulas. I request students, it is very easy concept. So solve more and more questions from your exercise. Any doubt related to those exercise questions, please do mention in the comment box and go through the textbook, because whatever content I have taken here to explain you is from your textbooks only. So after listening the lecture, it will be very easy for you. Let us proceed further. Why does this happen? What has happened here? Let us see into the picture. Why this? You can see a pot, you can see an earthen pot. In that a plant is there, and we have kept that plant in dark, correct? In dark we have kept it. So if a pot having a plant in it is kept in the dark, say me, what will happen and why does it happen? What will happen is the plant will lose its color. The leaves of the plant, it will fall down, correct? And there will be no process of photosynthesis. Why? Because there is no sunlight, there is no solar energy, so the requirement is solar energy. Why does it happen? Because there is no solar energy. See the second figure. On increasing the volume of a music system, the vessel in the house, the vessel in the kitchen, they start vibrating. Look at the cook and look at the utensils, how they are vibrating. It is because of the sound energy coming from this sound box, correct? See the third example. When we collect the sunlight on a paper with the help of a convex lens, the paper burn. Yeah, because of the sun rays are being converged together. It is converged and it is focused on the paper, point on the paper. What will happen? The paper will get burned because the solar energy is getting converted into heat, and because of which the paper will burn. These are why does this happen? This happens because there is some energy in every place, in every wherever you go on this universe. There is energy, and there the energy is in different forms, correct? It is in different forms. So we don't know what will be the form. It may be a solar form, it may be heat form, it may be electrical form, it may be in sound form. We don't know. There are different forms of energy. So why does this all happen? It happened because of energy. Now what is that energy? you know you tell me, to move any object from one place to another, what is required? You require energy, correct? You require some energy to move a stationary object. That energy is defined as the capacity of a body to perform work. Energy and work both are the same thing. Nothing is different between energy and work. Energy just defined as the capacity to perform that work. That means the outcome of an energy is the work itself, the work done itself. So the reason the unit of force, work and energy both are same. We know the unit of work, it is joule after the name of the scientist, correct? So the SI system is joule, and in CGS system the unit is Erg. Same is for the energy. Remember that the energy is the capacity to do work, and its unit is same as work. Then there are different forms of energy in this universe. Wherever you go, I said in universe, the form there you have learned that the energy exists in various forms. Those various forms are mechanical energy, heat, light, sound, electromagnetic energy, chemical energy, nuclear, and solar. These are the various forms, and these are having a very vast application in every technology. So you will study all these forms of energy, but not now. In this chapter, we are going to study two forms of mechanical energy. Those are potential energy and kinetic energy itself. Only the two forms of the energy which is a mechanical energy. Now just have a look on this example. As we said, the two forms of mechanical energy are kinetic energy and potential energy. See the boy who is cycling, he will climb the mountain, okay, and he will come down. See, When he is climbing, they say it is kinetic energy. When he is stopping at one peak of the mountain, at that time it is a potential energy. Again, when he is coming down to the slope, it is kinetic energy. So look at the girl, she is holding a ball. When she is holding a ball, at the time they term it as a potential energy. When the ball is under motion, she throw the ball. At the time they say the potential energy transforming into kinetic energy. That means what? Whenever the object is stopped, some energy is stored in it. When energy is stored, when the object is stationary, at that time there will be something related to potential energy. When the same object is under motion, at that time they say it is a kinetic energy. So because of the motion there will be something related to kinetic energy. So till now we have understood that when the object is stationary, when the object is at some position, they call it as potential energy, and when the object is under motion, at that time they call it as a kinetic energy. So let us see whether our understanding is correct or not. Let us proceed further and check out with the definitions. Kinetic energy, what will, you have to just see the three figures. What will happen in the following cases? The first case is what? The fast cricket ball strikes the stump. The second is what? The striker hits a coin on the carom board. Third one is what? The one marble strikes another in the game of the marble. From the above examples, we understand that when an object, moving object, strike a stationary object, the stationary object moves. Thus, the moving object has some energy, part or all of which is shared with the stationary object, thereby setting the stationary object in motion. Okay, that you can see here. Which is the stationary object here? The stationary object is stump and the moving object is ball. Here the stationary object is one marble, which is these are all the marbles which are stationary, and one marble which is under motion is held by this boy. The coins here are stationary and the striker here is in motion. So all the objects under motion are creating some disturbance to the stationary object, and the stationary object is again set into motion. So we can say that the moving object is providing energy to the stationary object and then setting the stationary object under motion, isn't it? So definition of the energy, the kinetic energy is what? The kinetic energy, which an object has because of its motion, is called as the kinetic energy. So whenever a stationary object will come under motion, at the time we say that it is having some kinetic energy. And previously when it was stationary, at the time which energy it had potential energy. So when the object is at some point stationary condition, it is having some energy stored in it, which is the potential energy, and when it is set under motion, it is kinetic energy. Kinetic energy is equal to work done on the object, which is force into displacement, and kinetic energy का formula is half mv square. You should remember, m stands for mass, v stands for velocity. Expression for the kinetic energy is very very simple. It is, you can see it is a long derivation, but it is very very simple. See, I will show you. You know force, what it is? Force is equal to mass into acceleration. We have to derive this. Kinetic energy is equal to half mv square. Okay, force is equal to mass into acceleration. It is similar using Newton's second law of motion. We know that force is equal to mass into acceleration. Use the second kinematical equation, which is S is equal to ut plus half at square. Here what we have to, first we have to come to we should understand the notations. What are the notations? It is very simple. Suppose a stationary object is there which is having mass m, moves because of an applied force. Okay, let u be the initial velocity. Since the object is stationary, the initial velocity u will be equal to 0. Let the applied force because of which the object of mass m is under motion be F. Let the applied force be F. This generates an acceleration A in the object, and after time t, the velocity of the object become equal to V. Okay, so displacement during this time will be what? Will be S. So m for mass, u for initial velocity, F for force. Acceleration is being set. Time t is there, which will give the object a velocity of v, and there will be a displacement in it because of the velocity, which is S. The displacement is S. Okay, so we are very much thorough with all the notations over here. So the work done on the object will be what? Because of all this, the work done will be equal to force into displacement. This we all know. Work is equal to force into displacement. Now this force is equal to mass into acceleration. S is equal to ut plus half at square. Initial velocity is 0 because of the stationary object is present. So we come to know that S is equal to half at square. Work done is equal to force into displacement, because of which force is ma and displacement is half at square. From equation 1 and equation 2 you can put the value in work is equal to force into displacement. There will be an equation 3, half m at square, because this a and this a will get squared and t is already under square. Using Newton's first equation of motion, which is v is equal to u plus at, initial velocity is 0, at will v is equal to at. Just put the value of at as v here in this equation 3, so it will come out to be half m at is v, so half m v square. See, kinetic energy is equal to half m v square. Kinetic energy, the work is equal to kinetic energy that we have already seen. So it is a very simple, half mv square. Simply you have to take the formula for force, then you have to take the second kinematical equation, substitute the value of u as 0. You will get some you will substitute force and displacement in the formula of work is equal to force into displacement. Use the first Newton's first law of motion, first kinematical equation. Substitute the value of at there. You will get that w is equal to half mv square, and that will be equal to kinetic energy. Let us go through an example. A stone having a mass of 250 gram is falling from a height. How much kinetic energy it have at the moment when its velocity is 2 meter per second. So they have given the mass, they have given the velocity, they have asked kinetic energy. Simple, kinetic energy is equal to half mv square. After writing the given quantity, you should write the formula, substitute the value of mass, substitute the value of velocity. You will come to know that it is 0.5 joule. Use your brain power, they say. What is the question? If the mass of a moving body is doubled, how many times will the kinetic energy increases? So they are asking us to find out how much the kinetic energy increases. First, when the mass was m, at that time the kinetic energy is half mv square. Then they say the mass is doubled. Previously mass was m. Now the new mass is m1, which is twice of the previous one, 2m. So instead of m, I will put here 2m. So half m, it will be half 2m v square kinetic energy, correct? So it will be kinetic energy, new kinetic energy, ke1 I will do. This 2 and this 2 will get cancelled. So the new kinetic energy comes out to be half mv. It comes out to be mv square, new kinetic energy. Previously the kinetic energy was half mv square. Now it comes out to be mv square. That means the kinetic energy is also doubled. So if the mass of a moving body is doubled, the kinetic energy will also get doubled. Potential energy. Now they say what will happen in the following cases. We have to decide looking at the examples. Water kept at a height flows through a pipe into the tap below. A compressed spring is released. An arrow is released from a stretched bow. Okay, so everywhere here the object is stationary. How I am saying? Which word describes the state of the object in this example? The first example, water kept at a height, that means it is stored, that means it is not under motion. A compressed spring, that means you have compressed the spring, that means you are storing some energy into it. An arrow is released from the stretched bow. The bow is stretched, that means before setting the arrow under motion you have stored some energy in it. So this all word, the stretched, the water kept at height, the compressed spring, this is a compressed spring, the stretched bow, this all are the terms which say that the potential energy is stored in it. There's some energy is stored in it. So before the setting the object into motion. So simple, the energy stored in an object because of its specific state or position is called as a potential energy. If objects were not brought into into those states, the object will not move, correct? It will not set the another object into motion. So we have to bring those object into those states, then only there will be some motion, and that is called as a potential energy before setting the object into motion, we have to store some energy, and that stored energy is called as the potential energy. Potential energy is equal to mgh, where m stands for mass, g stands for gravitational pull, h stands for height. Okay, now the expression for the potential energy: to carry an object of mass m to a height h above the surface of earth, a force equal to mg is required, and it has to be used against the direction of the gravitational force. The amount of work done at that time will be force into displacement. This is the concept of potential energy. Just there will be an object of mass m, and it has to be raised against the gravitational pull of the earth, and that force applied will be mg. Work done is equal to force into displacement. Force is mg, okay, and height is h, so work done is equal to mgh, and the amount of potential energy stored in the object because of the displacement is the potential energy, and which is equal to mgh. The displacement to height h causes energy equal to mgh stored in that object. So just we have to raise the object and store some energy. That energy is equal to mgh. Very simple. It is not like derivation of kinetic energy, just one formula, and we are through the value of potential energy, which is equal to the work, which is equal to the mgh. One small example related to that: 500 kg water is stored in the overhead tank of 10-meter high. Calculate the amount of potential energy stored in the water. This example we already saw here. The water is stored at some height, okay. Mass has been given, so you know the value of mass m, you know the height 10 meter. Just we have to calculate the potential energy, and potential energy is equal to mgh. We know what is m, we know what is h. G, whenever it is not given, we have to take 9.8, and since the work is done with the gravitational pull of the earth, the g gravitational pull is 9.8. So substitute the value, potential energy comes out to be 49,000 joule. It is very simple calculation. Now see, the Ajay and Atul have been asked to determine the potential energy of a ball of mass m. There is a ball of mass m kept on the table. What answer will they give? With respect to the Atul, what will Atul say? They have asked the potential energy. He will say that potential energy is equal to mgh, where m is the mass, g is the gravitational pull, and height h according to the Atul is h2. See, Atul is standing on the table, and according to him, if no Ajay is standing over here, Ajay is not standing over here at the time. According to the Atul, the height is h2, correct? The height is h2, so he will give the answer as mgh2. Now when when Ajay is standing here and Ajay is asked the same question, so what Ajay will say? Potential energy is equal to mgh1, because according to the Ajay, the height is h1, and according to the Atul, the height is h2. So both the answers are not equal, correct? So will they what answer will they get? They will get this answer and this answer. Will they be the different? Yeah, the answers will be different. What do you conclude? I conclude that the potential energy is not specific, it is relative. It is relative with respect to the observer. Where the observer is standing, according to him, what are the quantities, he will uh, give you the answer. Mass will remain the same, the force of gravity will remain the same, but the height will change, and because of the change in the height, the answers will be different. So the height of the ball with respect to Ajay and Atul are different, so the potential energy with respect to them will be different. So what we can conclude, that the potential energy is a relative term, it is with respect to observer. In the next lecture, we are going to proceed with the concept of transformation of energy and what are the laws of energy. We are also going to deal with free fall, and we will solve examples related to these concepts. I request students to keep watching this series. And the in short for today's lecture are energy and its forms. The forms of energy are there are many forms of energy. From that we studied about mechanical energy and its two forms, which is kinetic energy and potential energy. Remember the formula of kinetic energy, which is half mv square, and potential energy is mgh, and the keyword related to the kinetic energy is motion. Whenever the object is under motion, we talk about kinetic energy, and when we talk about the state of the object or the position of the object, at the time we tell about the potential energy. These are the two key terms which you should remember relating to kinetic energy and potential energy. Students should watch the series completely and should solve the question mentioned in the exercise. Thank you for watching. Don't forget to like, share and subscribe.